Here we are with section 2 of chapter 2 about quadratic functions. We see here a quadratic function in what is called general form. I have to make a note that a in front of the x squared cannot be equal to 0, because if it were, then what we would have would be a linear function. So we also have to have that 2 exponent over the x, not 3.5, but it's got to be exactly 2, and then an exponent of 1 over this x, and an exponent of 0 over that x, which I hope you can see. This is called the standard form, and on this slide I replaced the y with f of x because, after all, those are synonyms. And I needed to fix this slide. I forgot to. This is not standard form, this is general form. I think it's going to say standard form on all of these slides. I'm sorry about that. Okay, so we know that the graph of the quadratic function is a parabola. And it opens up or down, and the parabola, and hence the function, always have either a minimum or a maximum. Can't have both, but it's got to have one or the other. Other functions don't necessarily. A cubic function, as we'll see, might not have any of those things, but a quadratic function always will. And if you think about our transformations, then you will surmise that if the parabola opens up, then that leading coefficient a is greater than 0, and if it opens down, a is less than 0, and vice versa. If a is less than 0, it opens down, etc. The max or min is also called a vertex. This is a word which in Latin would mean turning point, just like reverse and inverse and so forth imply a turn of some sort. Our convention is to name the coordinates of the vertex h and k. The parabola has an axis of symmetry. Up to now we have seen symmetry around only either the x or the y-axis, but a parabola any place in the plane does have an axis of symmetry through its vertex. So since it's through the vertex, and since these are functions of y, or no, of x, that means they have to pass the vertical line test, and it also means that the axis itself is vertical, and that gives it the equation x equal to h. The domain and the range of the function, take a look. What do you see? You can see those left and right branches going on forever. That means that as they spread out forever, the domain is all the reals. The range, however, is not all the reals, because the function always has to have either a minimum or a maximum. So here are the appropriate restrictions on the range. And that's it for the introduction to quadratic functions.